Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Ladyada the engineer. With me, Mr. Ladyada on camera control and mic, and in the background, a sleeping Ada baby. We've got an exciting show.
Maybe.
Maybe sleeping, maybe not. We've got an exciting show for you tonight. Lots of new products, videos, 9 MPI, lots of it's not out yet, and more. Mr. Ladyada, what's on tonight's show, and what is that code?
On tonight's show, the code is CalLogger, 10% on anything that's in stock in Native Store, all the way up to 11:59 p.m. Talk about some live shows, including Show and Tell. Gonna do a little bit of recap from Desk Ladyada, including a great search. Got JP's product pick of the week, a little bit of time travel, some news about our jobs board at jobs.adafruit.com. We got some really fun, exciting advanced manufacturing made in New York City, factory footage. We got some 3D printing. We got INPI. We got top secret. We got new products. We're going to answer your questions. We do that over on Discord, adafruit.it/discord or discord.gg/adafruit. All that and more on, you guessed it, Ask an Engineer. So, as we get started here, don't forget the code is CalLogger. One programming note, we did a pre-recording of one of the segments in here because for the parents out there, we do have someone to help us watch our kiddo. We had a couple of different people. One broke a wrist. Our child didn't do it. We did find her from Krypton, this meteorite that landed, but no, it had nothing to do with us. Broke her wrist mini golf. And then another one, she was really proactive and she got one of the tests for one of the respiratory viruses that are going around. And she told us in advance, she's like, hey, like, I'm sick. And I tested positive. It wasn't COVID, but it was like one of the many ones that like everybody is getting something now. And so we try to arrange things so we have the show that we can do and have someone watching kiddo. But some of the times we don't. And so
The show is live.
yeah, we do a live show. We're always going to do a live show. So just bear with us if there's something that goes right or wrong. But we did a pre-recorded one of the segments just because it required a lot of technical things behind the scenes that we do. So
But the rest is live.
yeah, so you'll notice there's one Ladyada change of clothes in here, and
Quick change.
yeah, but we're not trying to fool anyone. We're just working parents, and we really love what we do, love kiddo, and we like doing all of it. We're pretty lucky, and she hangs out with us while we do electronics and more. In fact, at the
But
end,
she does eat a lot, which is why you should use that code
yeah,
to help us pay
she
for
eats
the
a lot.
food to feed me so I can feed her.
So at the end of the show too, we made a little video. She plays a little piano while Lady Ada designs electronics. She's only a few months old, but she's getting pretty good. So we'll show that at the end of the show. So anyways, just a heads up in case you see, I have to like juggle some camera stuff around here. And change your baby during the show. So anyways, in addition to that discount that'll help us pay for food for all of us at Avert, we have some freebies.
That's right. Beep beep. We've got freebies, $99 or more. We've got that half size Perma Proto, great for taking your breadboard projects and making them permanent. $149 or more. We still have the KB 2040. While supplies last, we will not have these forever. The pink PCB will eventually turn back into black. But for now, a pink Pro Micro pin compatible RP2040 board with STEM QT buttons and USB-C. It's a great microcontroller. Free ground shipping with UPS ground on orders $199 or more, and $299 or more. There's going to be a free microbit V2 in your order. This NRF52 baseboard has programmer built in and has lots of tutorials. It's great for kids or students at heart, with tons of sensors, a 5x5 LED grid, buttons, microphone, capacitive touch, and more.
Do a bunch of live shows. every week, including this one. Um, I like doing live shows. It's special. There's a connection that you have with the people that are watching the show that's a little different than just watching, unending 1 million channels. So that's why I like doing it. We're going to keep doing it. I didn't get a chance to watch the show until yet, but I will do that immediately after Ask an
See,
Engineer.
there's a mailbox.
What?
There's a mailbox.
Yeah, Liz was hosting. Thank you so much, Liz.
And Anne showed up officer gifts, probably.
Yeah, we're the video in the beginning of this show. That was a bunch of projects that Anne did as part of one project, which is the floppy disk with a screen on it. Super fun retro project. Bring back lots of memories. I put the floppy sound in there. So you'll see that project and more. We're going to be doing a lot more with that. And then some other projects came along. I think DJ Devin at the end had a neat one that I glanced at before we went live. So I think we're hosting next week. Who knows? But we'll have someone from Adafruit. Maybe it's us. Maybe it's someone else from Adafruit. And it's every Wednesday at 7:30 p.m. on, I guess we would call it Hacker O'Clock. That's what we do. That's what we say.
Mm-hmm.
We have Desk of Ladyada, and we do that on Sundays. And it usually is 2 parts. And then part 1 this week was
Okay, so this Metro M7, it's getting closer. It's getting closer. I worked on the tester this week. It's almost done, so you can get those Metro M7s in the shop. I also worked on some Bones boards, which I'll show in more detail. So I did an RFM slash LoRa Bones and an e-ink Bones. That's in addition to the DVI HDMI output Bones that we did 2 weeks ago.
Yeah.
And that leads into
Yeah, we do the great search. This is it's been really handy over the last couple of years. It's how to find stuff on digit.com and Ladyada user Power of Engineering, and I think you're probably one of the top experts of searching DigiKey
I'm so good at
on
searching.
planet Earth. So you show folks how you find the things that you're putting into your designs. What did you show this week?
So this week I showed off HDMI slash DVI connectors. So there's HDMI, mini HDMI, micro HDMI. But there's also DisplayPort and DVI-D, which are all the same protocol but different like pluggy parts. And I showed basically how to, there's a lot of Jelly Bean HDMI ports, and I just showed a couple options, what I searched for, and variants that are available on digikey.com. So you can, as soon as I release these Bones board files, once I've tested them, folks can check out the Pico DVI library we wrote.
All right, and then JP's workshop is every single week on Thursdays, but on Tuesdays we do JP's product pick of the week. That's where we broadcast live from inside the product page. It's one of the only shows in the world that does that. So here is this week's highlight. Take it away, JP.
It is the LCD character backpack. I took our board, our little LCD driver board there, and put some socket headers on there. You can plug that in like that. Okay, so here you can see I've got 4 lines on this one. I've got some blinking cursor, which is part of the library. Notice the J and P, those are a custom font, so I did a couple of custom letters. Same with that little sort of Space Invader guy who's flying along on the bottom there. It's a custom, so I filled 3 of the 8 custom slots, and then you can just call them using an address. Here you can also see I'm doing some of the sort of automated scrolling, moving. Here I'm using the little move right command, and then I'll run this set of text and then use scroll to kind of move that off to the side and rearrange that. That's my product pick of the week this week. It is the LCD character backpack with I2C and SPI and Stemma QT connectors.
5 p.m. on Fridays, we have Deep Dive with Tim, and I thought I'd do a little bit of time traveling. Got some news going on here. Ladyada. So first up in the world of time traveling, we have something on our site every week, every day, every month. Something or someone is being celebrated on the Adafruit site. It was just Black History Month, and check out all the posts. You can check it out all year, but February is Black History Month, so you can check out all our posts there. Also, SparkFun had a bunch of good posts.
Oh, cool.
And I think that's one of the things that we've been trying to encourage and support and see. So we posted up their posts on Adafruit, and the more we celebrate one another, the better it is. That's why we're all here, sharing. I think I'm going to be able to finish writing my little article. I think the maker world or the engineering world, we all kind of, well, most of us kind of approach it like skateboarding, where it's like, oh, you did a trick, and then I built upon that trick, and then we keep doing tricks, and it's not a competition in the same way. It's not like I'm better than you. It's like you're actually learning from each other, and you can only do the tricks together. but you're still kind of pushing one another, and it's a very like wholesome, good thing. So part of what we do on our website is similar. It's if you see people that are like you from wherever you're from, whatever walk of life, whatever your background is, if you see someone like you doing something that you want to do, like engineering, you're more likely to do it. So this month is Women's History Month. And not only do we have a lot of blog posts, but we also have guides that have women who made the electronics. So we have like gift
We have
guides.
a lot.
Yeah, so I thought we'd just go over to that right now. So if you go to adafruit.com, WHM23, and you'll get all of our posts. You can also look at, we've been doing this for a while. This isn't the first year, ain't our first rodeo, as I say. And then if you want, you could go to, I think it's WHM 23 Explore, where you could just click one of the links. And this is electronics designed by women. So you can look at the learn guides, you can look at all of the actual products that we have in the store. And I think we're one of the few resources that kind of collect this all in one spot. So check it out. And if there's an amazing woman that's built and shared, did anything, send it to our team and we'll get it up on the website. I do have some other news. I think I'll just bounce right into our jobs board news. So our jobs board is going to change. So what I thought I would do is let everyone know how it's going to change. So we've been doing the jobs board for a while, and it's a free service that we do for makers out there. So you could post your skills, or you can post, if you're a company and you're looking for people, you could post the job. It's just another website that we've been maintaining. We use GitHub for our newsletters and Markdown and GitHub pages. And we also have the Learn system, which is an authoring tool. So instead of having 10 different authoring tools for 10 different things, we want to start, this phrase is like eat your own dog food. So what we're going to do is take down the jobs board, which is a WordPress site, and we're going to have it first part of like the Adafruit kind of content management system we have, but then we're going to have it work with our Learn system.
Mhm.
So anyone with a Learn account could post a job, and it's easier that way. So we have 3 jobs at Adafruit right now. You can take a look at it. But what I thought I would do, because I'm going to be taking this down soon, is give Goliath, who just posted up a couple jobs, a little extra up. So if you do firmware and you want to do cool IoT stuff
IoT,
using Adafruit things,
Wi-Fi,
yeah. So
sensors.
Goliath is a startup that does that. Check it out. They have 2 jobs that they just posted up: lead firmware engineer and field application engineer. And this is IoT firmware. You could check out the job application. You could check out what they're looking for. We know people. I think the 2 people that we know there, Mike, the former editor of Hackaday, and then
Oh,
the other person, Chris Grammel,
Chris Mel, yeah.
who's there,
Mike and Chris.
who I think folks know Chris probably from
And Bauer.
Aunt Bauer and a few other places.
Yeah, and like embedded
Yeah.
electronics.
So these will be here just for a little while, but that's what we're doing. We're changing it up so it's easier for everyone to use it. Also, like the less servers you have to maintain, the better.
Yeah.
It's just like another instance, another server, another thing, another surface area that gets like hammered from like denial of service attacks, and just like everything is kind of like that on the internet. Okay, let's do some Python on hardware, Ladyada.
Mhm.
Blinka, blinka, blinka. So, we have a newsletter that's pretty awesome, and
It is awesome.
yeah, it
They
is.
send links to it all the time.
Yeah, and each week we go over some of the cool things in it. Please subscribe, and would appreciate it. I would appreciate it. Everyone would appreciate it. We spend a lot
And
of
it's
time on this.
really good stuff.
And it has just about everything that you can imagine that has anything to do with Python and anything to do with electronics. From GIF playing with Circuit Python to a lot of this neat auto-generated code with like ChatGPT and Pong. There's just a lot of neat stuff that's in there this week. However, the thing that we're going to talk about this week is this is the special guide that you wanted to have made from the team, which is all about CircuitPython safe mode.
Yes.
So this was interesting to me because when we were doing a lot of testing with AdaBox Cricket, I was breaking it constantly because it was like, this was new. This
Yeah.
was like, oh my God, like we're doing Python and robotics and all that. And we had to do a bunch of stuff that kind of like, I would like, oh, let me remove the following like frozen libraries or like whatever it was. I'm just like, I need to like basically like an old school Mac.
Yeah.
How do I make it so
It's like hold shift down while you
how do yeah, how do I like,
disable the
I'm like, how do I do
extensions.
safe mode? And you know, it's been a while, but now it's kind of like possible. So you can mess around and then you can boot into a safe mode
Yes.
if
Well,
you get in some trouble.
we've always had the safe mode available, and sometimes you can double or triple click reset to get into it. Safe mode is basically if you had like a hard fault or you had an uncaught exception or I'm trying to think, is it like a low battery, like a brownout? We have a couple different reasons why you might end up going into safe mode. And if you're a beginner, it's really nice that safe mode kicks you out and like kind of stops running stuff so you can see what happened. Like you can see the exception trace. However, if you are not a beginner, you might want to do something special on safe mode. Like for example, if there's a brownout, maybe you want to like stop, check the battery, save the data to a file. Or if you're doing an IoT thing, maybe you want to send, what's called a last will over MQTT and say, "Hey, I'm about to go offline for a very long
It's like a
time."
dead man switch.
It's a little bit of a dead man switch. It's outside the scope of the code.py. Like you might want to do certain activities. This is something I would have found really handy while doing like MagTag. I would always end up in safe mode, and it was like, shoot, like I didn't want to actually. I wanted to just go to sleep and restart. I didn't want to actually.
There was times when COVID was peaking in New York City, and we wanted to look at the infection rate, and then the data source or something would happen, and we'd wake up in the morning, and the display would hit an error
Yeah.
because like the database was down or
When
something.
you can do like a finally, but it's
Yeah.
basically like we didn't have this structure built in, but now we do. So Dan Halbert, who's a core developer, wrote a guide, what you can do is you have a circuit. If you have a file called safemode.py, that will run when in safe mode, and what it can do is exit safe mode, or it can again write errors to a file or somehow track what happened. So it'd be good for telemetry analysis, etc. It's a kind of a more advanced feature, but if you're not used to safe mode, like a lot of microcontrollers, if try to read or write address 0 in memory, it'll hard fault and it'll just like the watchdog timer will kick in and it'll reboot you.
I like the descriptive messages. It's like you're in safe mode because.
Yes, this is also nice. It's updated the description.
Make sure you're providing enough power. Press reset to exit safe mode. That's really neat.
Yes, but you have to click reset. So that's the problem is if you weren't there to click reset, it doesn't automatically reset. Whereas if you're, if you have a brownout, you might want to do something with that information. Anyways, it's in the new guide on Learn. Check it out.
Okay. So in addition to the MagTag one that you were talking about, could you have this safe mode interact with something like Adafruit IO? Could you have it like?
Yes, you could. Like if you have something, you have something on a boat and this error occurs, and it's a rare occurrence, you might want to log when that happens. I'm speculating because I've actually written this, but what you could do is have safe mode, write something to the non-volatile memory and say, "Hey, I failed at, this time," and then boot into the main program. The main program sees like, "Oh shit, I just got out of a safe mode," and it sends a message to Adafruit.io saying, "Hey, it's Sunday at 6 a.m. You had a failure."
That's why the data I'm sending.
That could be why the data.
This is getting really neat because a lot of people do stuff with those little micro satellites with CircuitPython. I just like the idea of like this like very smart thing that can operate on its own and do things and then give you a error message later.
And it knows why, which is, if you're used to, like, I actually really like using this in Arduino. You can look at the reset flags and see like, why did my microcontroller reset? And you can, even if you don't have a full debugger, it can give you some idea of like what occurred. So it's a little bit more advanced, but it's something that I've been looking for, and I think it's especially for IoT stuff, it's very handy because, to be honest, like the ESP series could sometimes kind of just like go off into the woods.
Yeah.
And it'll hard fault, and you're like, I don't know why, and it's very hard for us to debug. But at least your project isn't stuck.
I think this particular feature thing and how we do things like you can have CircuitPython not show up as a drive if you want to do something with keyboards. These are like very interesting advanced features that really make it a well-rounded choice.
Yeah.
We just did this floppy project and Anne did an amazing job, and like Jepler and then Mark did it. Like everyone worked together on this, and like these GIFs are cool and everything. And it's not a project that I would say you could do with anything else. And I kind of wanted to be like, hey, like not offer a bounty, but like, hey, is there any other way to do this? Any easier way with lower cost hardware and not like, just find an like you could find something else that works with Adafruit stuff if you want, like that's fine. But I'm saying like, no, like this would be completely written in something else. Like, is it even possible? And it's like, kind of no. It's really hard to do all this stuff.
Yeah.
But,
This is very advanced.
yeah. Anyways. So,
but we make it easy.
Yeah. So good work. Okay. Don't forget, sign up. Adafruit Daily.
In your mailbox.
We do not spam you. We do not harvest your emails. We don't do anything like that. Let's go to some guides. So we have a bunch of guides, lady. We have, I think, let's see. Let me go to new guides. It's like thousands. What's on the big board this week?
Okay. Actually, okay. So, there's a couple updated guides. All these QT Py, ESP32, and Feather ESP updated guides are because Brent has been cranking through the Whippersnapper Essentials pages. If you want to use Whippersnapper on these boards for no code IoT, check out them out. He's gotten a good start on them, and there will be more later. We just talked about CircuitPython safe mode. If you want to have special code run in safe mode, and then you can use the non-volatile memory, perhaps, if you want to like pass messages from the safe mode runtime into the code.py runtime. I'll say the 3D printed light up kaleidoscope just came in, and so I didn't get to take a look at it.
I saw
but
this.
it looks
It is super cool. So,
yes.
If you're looking for a project to do with the wireless LEDs, this is it.
Yeah. So this is I think Geek Mom.
Yeah.
So she did a project with laser cut, and she's like, I want to redo it with 3D printing. And I was like, yeah, absolutely. Post it up. And then what's really cool is it uses the LED beads and the coil is on the back. So like as you're looking, it's actually lighting up from the inside. I when I was a kid, I had a kaleidoscope, which was really cool. But of course, you have to point at the sun or at the moon or light. This lights up on its own. I actually kind of want to build this. This is really cool and tricky.
Yeah. You know what would be neat with this too is once you make one of these, we could put it underneath the overhead or one of our cameras, and we could project it either home, or we could do a live stream. We can get music.
I think kaleidoscopes are under.
I need a black light, and then we should go to Burning Man, and it's trippy.
Okay. Wait, we're going to guides. Go back. I think there's more guides.
Is there?
Okay. Yeah. Okay. Jepler published a guide for the Adafruit floppy Featherwing. This is our Featherwing that you would plug into. What we recommend is an in RP2040. And then using PIO, you can read and write floppy disks. We're going to have more tutorials. This one's just getting started. You can use Flux Engine or Grease Weasel on cross-platform through the Feather and the Featherwing to read and write raw fluxes for floppy disks, good for IBM PC, but we were also able to read some Commodore 64 and Mac OS classic, like original style floppy disks. So there'll be more to come. We have actually a lot of documentation. The thing is, we just have to like sort it because it's like it's so like floppy disks like definitely were a thing we did. We learned a lot, but it's also like really confusing. Okay, so we got all these updated boards are because there's the essentials pages, AT-Tiny breakouts. We added the AT-Tiny 816 and 1616. Trevor published his Matrix Portal boxing interval timer, so it's more boxing from him. So you put together the font and the timer, and then using the buttons on the side to indicate, like how long you should be boxing for. And then we've got an update to the I Squared C SPI LCD backpack. It got like a huge redesign. It's one of our first products. It's like product 200 or something. It's got, and we featured it last week. It got a complete redo. It's now 3 to 5 volt compatible. It's semi-QT, plug and play. It's got a nice, better potentiometer. It's got a nice silk screen. So it's shape compatible, but a big upgrade. And then let me see. Okay, of course, we've got the guide from Anne on the floppy disk. Do you want to feature that later?
Well, I jumped the the floppy
The
here.
floppy gun.
Yeah, this is a 3D explodey diagram that.
And we've got the
did.
video from.
Yeah, we're gonna show the video in a minute, but I when you said floppy, I'm just like, oh yeah, floppy.
Floppy.
So I added.
Well, we just double the flops. It's a double-sided floppy. You like flip it upside down. So we'll show the video for that from Noah and Pedro. That was a collaboration with Anne, who wanted to make live a nanoraptor project, and then so I keep scrolling. A lot of all these Pipeworld things got updated for Whippersnapper, and then the music was from last week. So I think that's it. That's still a lot.
There's a lot of guides. So go to learn.adafruit.com. We're doing a ton. Let's do some factory footage. I have some fun stuff this week for that. That's factory footage. All right, we're going to do some 3D printing projects and more with Noah and Pedro. Don't forget to tune in for their show, the longest running 3D printing show every single week. 3D Hangouts with Noah and Pedro. Let's do the floppy video, and then we'll do the speed up, and then we're going to go right into INMPI.
You can build a retro-inspired gadget using Adafruit's PyPortal, CircuitPython, and 3D printing. This project was inspired by Dana Sibera, aka Nanoraptor, whose Photoshop renderings give us a peek into an alternative past filled with whimsical computers. This 3D printed enclosure resembles a 3.5-inch floppy disk, also known as the iconic save button. Unlike the original storage devices, this one uses CircuitPython to act like a small USB drive that also shows files on the device's color TFT display. The files on disk are shown as icons with file names. In my build, audio files, folders, and images are rendered as classic icons from Mac OS 9. You can tap on the next and previous icons to see more files so you can page through all of the documents stored on disk. The PyPortal is an IoT dev board featuring an ATSAM-D51 and an ESP32 chip bundled with a 3.2-inch color TFT. The code for this project was written in CircuitPython by Anne Barella using the Display.io libraries. CircuitPython's native graphics and custom fonts made this project easy. Check out the Learn Guide for full breakdown of how the code works and how you can customize the bitmap images to make it your own. You could easily skin this design for your favorite operating system look and feel. Our enclosure was designed in Fusion 360 and snap fits together to make an easy assembly. Check out our GitHub repo to get 3D models of Adafruit boards. You can choose your favorite colored filament to 3D print the parts on an FDM 3D printer. The Pi portal features mounting tabs that are secured to the built-in standoffs using hardware screws and nuts. The back cover snap fits onto the case and features openings for the USB port and microSD slot, along with a button actuator for the reset button. The sliding door is 3D printed separately in a silver colored filament and snap fits onto the slot on the front side of the case. We hope this inspires you to check out Adafruit's Pi portal and CircuitPython for your next whimsical project idea.
Hi, NPI brought to you by DigiKey and Adafruit. This week it is NXP. Ladyada, what is this week's INPI?
Well, it is M7 week here at Adafruit, with just a coincidence, or maybe it was on purpose. We're releasing our new IMX RT 1011 M7 Metro, which uses a chip in the same family as this week's INPI, which is the IMX RT 1040 series. This is a new chip in the illustrious IMX RT 1011, 1010, 1020, 1040, 1050, and 1060. I think there's even 1160 now. A wide range of chips, and this one is right in the middle. This is part of what they call the crossover MCU series. So a lot of people here, watching or listening, they've used microcontrollers such as 8-bit PICs or Atmels, or maybe they've used even 32-bit Cortex M0s. If you want more M's, you can go from M0 to M4, and then from there on to M7. So the M7s are very fast processors. This one, the whole family, they can be clocked up to 1 gigahertz. This particular chip, the 1040, is a 500 or 600 megahertz processor. There's also some that have a separate subprocessor, a Cortex M4 at 400 megahertz. They have a ton of SRAM that can be tightly coupled. They can have external RAM. They have built-in DC-DC converter, so you don't need a separate PMIC. Graphics, external QSPI or Octal SPI flash memory for storing code and files, and then NXP security as well. So this is the Metro M7, which is our first board that we've made with this series, and I learned a lot getting this board together. So the IMX RT 1011 is kind of the entry-level version of this family. It's like a microcontroller, but it runs really, really fast, and it has this M7 core. We've paired it here with an ESP32 for Wi-Fi and possibly Bluetooth add-on. Some things that are neat that you can see here is this is a 2-layer board. These chips are designed to be used as low-cost upgrades from, say, M4 or M3 chips. You don't need a separate PMIC manager for all the cores. You just need You see on the top left, there's inductor, capacitors, passives. On the right, there's inexpensive QSPI memory. We use the WinBond W25Q JV series. This is 64 megabit, 8 megabyte. And you just give a 3-volt power crystal, and you're pretty much ready to rock. It's got even built-in USB. To program these chips, what's recommended is using the MCU Expresso IDE from NXP. It's kind of all-in-one IDE setup. I will say that I personally haven't used MCU Expresso. Instead, I just use ARM GCC, and the NXP SDK work really well. And I just use it on the command line. This particular series, the IMX RT 1040, like I said, it's kind of in the middle. I'll show you the whole series of what's available in this family. As you expect, is a Cortex M7 with, of course, floating point support. It runs at 600 megahertz. If you want it for, I think, the full temperature range, you drive it down at 500 megahertz. But of course, you can pick what frequency you want with the PLL. It's got the built-in DC-DC converter, so you just need an inductor and some capacitors and some passives to run that. Inside is 512K of SRAM, which you can use as tightly coupled memory. Why you need that? Because there is no built-in flash memory. Instead, you have to wire up an external. In my case, I've wired up QSPI NOR flash. You can, of course, also use parallel NOR flash or eMCC or NAND, as shown here. QSPI is kind of the cheapest and easiest and uses the fewest pins. But then if you want to get instructions off of the for the firmware that's running on the chip, you're bound by how fast you can get the firmware code off of that QSPI NOR flash. And so by dividing up some of that tightly coupled memory, maybe 128K, you can cache instructions. So if you're running in a loop, your large enough loop, you can cache the whole thing in the tightly coupled memory, and you'll get the benefits of that 600 megahertz processor without being slowed down by your, whatever, 100 megahertz maybe at the most speed of your flash memory. One thing that the 1040 kind of adds that above the 1011, 1010, 1020 series is it does have the graphics support and the LCD controller, so you can use a dot clock style TFT, not just your standard SPI TFT. And it comes in 2 packages, which I'll show you. They're both the same pinout 169 BGAs. One is 0.65 and one is 0.8 millimeter pitch. So it's designed for easy routing. Lots of peripherals. I'm not going to go through all of them because there's a ton. SDIO, 8 UARTs, 4 I2Cs, 3 SPIs, FlexIO, which is quite interesting. It's kind of, if you've used PIO on the RP2040, FlexIO is kind of similar. It's sort of this all-in-one. You want to kind of do other protocols that might not be supported natively. You can mimic them with FlexIO. Lots of I2S. This the 1011 series doesn't have CAN or Ethernet, but these do. It does have one USB high speed, which can be either peripheral or controller. However, it doesn't have 2. Some of the 1050 and above have 2 USBs. All memory stuff, like I said, in the middle, there's that parallel LCD. You've got enough GPIO, you can control those 24-bit displays where you have 24 bits RGB, VSync, HSync, dot clock, etc. And ADC, no DAC, but there is I2S output and lots of PWMs and timers. If you want to use the USB core for this chip series, we do have support for the NXP IMX RT and TINA USB. TAC, one of our developers that's supported by Adafruit, has done an excellent job adding support for the NXP series. The LPC series actually was one of the first chips supported by TINA USB, but we definitely have support for the IMX series as well. It's open source and a great way to kind of start structuring your project. Again, if you're using ARM GCC, which is what TINA USB builds in. We also have a TINA UF2 bootloader. So there is a built-in bootloader, a ROM bootloader, and it's very fast and it works quite well. But if you would like to have a user-friendly bootloader, we have a second stage bootloader built on TINA USB called TINA UF2. And it's a drag and drop. You create these UF2 files that you might be familiar from our SAMD processor chips and RP2040 chips use that format for drag and drop programming. But again, there's this ROM bootloader that you don't have to worry about, and you program it with a command line tool that's available on any operating system. So, if you want to debug it, you'll need a JLink, but you don't need one to program it, built-in programmer. As we mentioned, these are available in 0.65 and 0.8 millimeter ball pitch BGA. They are designed to be routed onto a 2-layer board, and they do have dev boards that are 2-layer. Just to prove it, you don't need a 4-layer or 6-layer. I mean, you'll of course benefit. You'll have a bigger ground plane. Maybe you'll be able to fit your parts tighter because you don't have to route around them. But it's designed to do a fan out on an inexpensive 2-layer board. So just check the application hints. They do give you suggestion on how to do the fan out and the layout. And this is just from the NXP fan out recommendation. They will give you, hey, here's how we suggest you do the spacing and DRC rules to make sure that your IMX processor succeeds, in your BGA design. Because if you look at the Metro, it's the TQFP. And here's the rules for the 0.65, just here for your reference. So this is, again, part of the series of IMX RT chips. Starting from the bottom, again, the numbering is a little confusing. The RT1010, there's only the 1011 in existence. The 1040, it's actually the 1042. So like that last digit is sort of like a series of parts. So you can see you start with the RT1011, which doesn't have Ethernet or CAN bus and only has one USB and doesn't have graphics, and you kind of move up from the bottom. 1020 doubles the amount of RAM to 256K, and then the 1040 doubles it again to 512. But it's also the first one where you move from a QFP or QFN to a BGA. Still, it's 0.8 millimeters, so I really think, even though prototyping might be a challenge, any pick-and-place house should be able to handle that processor. And it has the graphic acceleration, lots of I2S and SPDIF, again, lots of peripherals. And it's not mentioned here, but it has 2 Flex IO peripherals, whereas I think the 1050 only has 1. So they've kind of bumped up some of the peripherals. The full table isn't here, but you can check it out on the NXP website. And then, as you work on the 1040, if you're like, oh man, I really want camera interface, or maybe I want USB host as well as USB peripheral, I want 2 USB ports, you bump yourself up to the 1050, keep going to the 1060 all the way to the 1180, which is quite a beast with built-in 1 or 2 megabytes of SRAM. The Flex IO is kind of the most interesting thing here. Again, you can emulate, there's a lot of peripheral buses, but maybe your pins are being used by, that parallel TFT, or maybe you need like another 3 UARTs. You can use Flex IO to mimic a lot of these. Note that it says for the 1010, but it's for the entire IMX series. They all have the Flex IO, and the 1040 has 2 of them. For the display, again, there's no camera, but there is a display. It says display and camera. I guess you could mimic the camera again with Flex IO. For display, note that you do have to have a frame buffer, right? So you will have to wire up external DRAM. I can show you on the eval board. It looks like there is DRAM on there already, so you can kind of follow their layout. You're going to use, a bunch of pins for that, and then you'll use a lot of pins for the 24-bit parallel RGB LCD. But again, it's pretty rare to find a inexpensive processor that can drive a full TFT display that doesn't have like a massive number of pins. I mean, this does have a massive number of pins, but it's easy to route. The only other chips that basically have those displays, which are kind of specialty displays, where they get very, very expensive, whereas this one's pretty affordable, considering it can drive up to I think it's like 1000 by 700 pixels. So, fairly large, like 10 inch diagonal displays. And if you want to get started, the 1040 just came out, but you can expect that we'll probably add it to the list. We do have CircuitPython, so you want to use that as a core for your development. It's available, and we're adding more support, especially since we're releasing this first Metro M7 into the shop finally. So check it out if you also want to use CircuitPython, which is MIT licensed, as a building block for your design. But we'll probably end up adding FlexIO support, the parallel TFT support, and USB host support for this series of chips through CircuitPython. And when I wrote the test code for the Metro, which I wrote in ARM GCC using the NXP SDK, I definitely cribbed from the CircuitPython code. I was like, well, how do you do the analog reads, or how do you like set the pull-ups? Oh, hey, we have some example code ready to go. And also recommend getting the eval board, which was not too expensive and has everything. So you can see kind of in the middle left there, there's a micro E socket, and there's also Arduino socket, NXP chip in the center, and then there's like a microphone and like headphone out, and there's also a on the top left there's an M2 socket where you can plug in Wi-Fi. So this is like quite a beast. We tend to target when we develop CircuitPython, we target the eval boards because they're pretty plentiful and they kind of have everything on them. I'll show this one on the overhead. It's quite big.
Yeah, and it's available on DigiKey.
Yes, it's in stock.
Stock.
About $10 a piece, which is a really good deal considering you get the SRAM built in. You only need, like I said, passives, crystal, small inductor, and QSPI flash. Maybe add like another $1 to your BOM. This is very affordable when you compare to other M7 boards like the STM series, which you can't get anyways. This could be a very nice upgrade. It has a lot of the same features that you would expect from other well-known M7s. So let me hold on. I'm going to back up my this board is so chunky. I'm gonna back up my overhead. Okay, so this is, and this is a little booklet that came with it. So this is the EVK, which I picked up again, a huge chip in the center. Looks like this is the DRAM, micro SD, micro E socket to use micro E boards, Arduino-esque header socket, M2 for Wi-Fi. It looks like there's audio. Oh, this is like is a codec. Hold on, this is a this is a WM8960, our favorite microphone and audio output I2S codec. Some audio outputs, Ethernet. Again, this has built-in Ethernet. It does have, you will need a PHY, and this is probably the PHY for it. And then there's probably inductors. The transformers are inside here. This is that one inductor that you need for the DC-DC converter built in. And then there's the crystals. There's 32 kilohertz and 24 megahertz. And then this is the programming and debugging interface. This is probably running some, NXP debugger interface code, or maybe it's JLink or something compatible. So it's a lot. There's a lot going on here. Buttons, DC input, and then this is USB for the debugging. I think maybe I don't know, USB for native. Oh no, here it is. Here's the USB native. So this you can have on the go. So if you want to have this be host, you would get a USB host adapter. And then on the bottom, we're not done yet. On the bottom, you can see the parallel TFT 40-pin connector. And this is a 6-pin connector, which has a pin out for capacitive touch. Almost certainly this looks like it's goes together. So you'd have a capacitive touch interface over I2C here. And parallel TFT over there. And then don't forget, for that, you need to buffer the display. You'll have to pop on some extra RAM, which is probably what this chip is. And then I wanted to show real fast the chips themselves. Now we got to go really small because these are very small chips. Oh, 1 second. Okay, so this is again the same chip, right? But one of them is 0.65 millimeter ball pitch, and this one is 0.8. So I'll flip it over so you can see the comparison. Which one do you choose? Well, 0.8 is easier to route, but it's bigger, and 0.65 is nice and compact. You can still do it with a 2-layer board, but you're going to have, a very good process for your PCB manufacturer. So pick which one. Same material on the inside, just a different package on the outside. So that's the IMX RT 1040 series. So check that out. And then Don't forget to pick up a Metro M7 if you want to get started with the crossover MCU series.
That's on MPI.
On MPI.
All right. So don't forget the code is a cow logger, 10% at Adafruit store, all the way up to 11:59 p.m. Eastern time, or when I fall asleep or wake up because of baby schedule. Let's kick it off with some new products ideas. This is what we've been waiting for all
Yay.
day. We did it. We're almost here. Here we go.
New, 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 new. New, 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 new. It's time for a new.
Yeah. Okay. Yeah, we were just talking about Old McDonald How to Farm because we're letting our kiddo react to things, and he seems to like that song. So, speaking of things to react to, though,
Still coming
so
soon,
close.
but the
Any-
photo's been updated.
Any second.
For the Metro M7, do sign up. We're going to put a small quantity in, I believe, later this week. It'll be probably next week's new product, but we'll run out before next Wednesday.
Yeah.
We'll try to notify people, including people on the Discord, especially if we don't notify everybody, because there's a
Yeah.
couple thousand signups. We're going to have like about 100 boards to put in the shop to start. But do sign up if you don't get notified immediately. Don't worry, we will be making more.
Next up.
Next up, another Raspberry Pi 3 camera module came in. This is the not no IR. This is the normal camera module 3 that's not wide. So it's kind of like the one I think people are going to want the most. This is in stock. So there's like the no IR, wide, normal, and now the everyday wide and normal. And we're going to get some photos and videos of all the camera options and like what it looks like. This is the new like super fancy 12 megapixel camera module V3 that has autofocus, really high quality, great for any camera projects, and it's like the same price as the camera V2.
Next up.
Next up, we've got an update. This is an update to an old familiar favorite, the capacitive touch shield for Arduino. So we've used Penguin to make the fonts really nice. We've also moved the reset button to be right angle. IRF is still there, and the Stemma QT port is also new. We added that as a little spot. I thought I could show a quick demo because capacitive touch is nice. This is a beautiful display. And it's got a wonderful capacitive touch screen. I will note, capacitive touch is more expensive than resistive. The resistive touch is out of stock at the moment, but will be coming back because we have to redesign it. So this is the capacitive touch. Let me autofocus it. So the colors are a little bit washed out just because it's a screen with a monitor with a screen. Let me see if I can.
Yeah, for this you might want to turn the light off. Actually.
You know what? Yeah, you're right. Look at that.
Yeah.
Yes, it's still washed up, but still, so it's a nice capacitive touchscreen, and we've got this little painting demo for it in Arduino. But you know what? It actually works in CircuitPython as well. It's got the FT 2602 or 2606 capacitive touchscreen. It doesn't do multi-touch, but it's very, basic and gives you the 240 by 320 pixels to touch points, and then it's got that 320 by 240 I-Align 9341 screen, all connected over SPI for the screen and I2C for the capacitive touch. So the big update, as mentioned, on the side now we've got this reset button on the side that's easy to get to, and a SemiQT port for adding I2C sensors easily. We've also got an update to this 2-inch IPS TFT display. As people have been noticing, all of our displays have been updated to have iSpy connectors. iSpy is kind of like Stemma QT for plug and play SPI displays. Usually you have so many wires that you have to wire up to get these working, and it means that it's like hard to kind of mount the display far away. And like I've seen people have a lot of difficulty with having the wires break off or short to each other or soldering issues. So this is it running the demo off of a Cutie Pie, so I can show it in the overhead. I can show what it looks like. So it just means, and this is actually kind of great for me because I can show off this demo. Here, the screen protector.
Yes.
Thank you. Yeah, that's very enjoyable. So you've got this display, and instead of having to solder all the connectors, this nice flip top FPC connector goes from here to, whatever your dev board is here. I've got a little breakout board to a stomach QT, so the display can go anywhere. Easier to mount, easier to wire. Basically a no soldering solution as long as you've got the matching iSpy connector on the other side. So this is, otherwise it's the same pinout, display, same SD card, same, level shifter. And we also did a nice silk screen as well with Penguin.
Alrighty. Next up.
Oh, actually, can we go to this one? Yeah.
Okay, then we'll go.
Yeah, because it's another display. So
Oh,
this is another this is a 1.44-inch display. It was one of our oldest products, 128 by 128 pixels. These were popular displays, popularized for like keychain image viewers. I don't know if you people remember those from like a decade ago. It was one of the first displays that was available that's like basically SPI, low cost. It's not an IPS display, but it does look quite nice. And the update we've done is like the other displays.
Yeah, we're
Here,
gonna go.
it has now an iSpy connector as well. We also made the level shifter a little bit smaller to make room.
Like I'm making this way easier now.
Yeah, it's
If
just
you have this
plug and play.
connector, then you can like it's like cool.
And it's standardized. It's like everything we're doing
Yeah.
with displays has them. And of course, we're going to make feather wings, and we have a breakout just to get started. But really, we saw a lot of customers that were just having issues with. There's just so many wires required, and
Yeah,
it's so
you
easy.
can't really-
It's like you can't see it because the displays, and then you want to mount the display. So this solves.
So you
that
never
issue.
know if your thing's not working. You never know what it is because there's so many wires going around.
Yeah.
All right, and then you want to do the pliers.
Yes, these are another set of crimpers from Engineer. They're a Japanese crimping plier tool company, and they make really good stuff. We've carried their other crimping pliers. So, I do recommend if you're going to be crimping connectors for, JST or Molex, if you can afford it, try to get the official crimper because, of course, it's going to work great. Or just get pre-crimped wires. But if you can't, the crimpers that are made by Engineer are really high quality. They have really good results, and they have good instructional videos to get you started with them as well. So this does like a range of sizes. You can look at the product page and the data sheet for the specifics, but basically your standard small wire crimps that most engineers are going to bump into that are not electrical grade, they're electronics grade.
And I hope they have like a video or advertising they did. It's like, hey, hand me those crimpers over there, and someone's like, well, there's a bunch of crimpers over here. Which ones are yours? Engineer.
Yeah,
What? Oh,
I
oh,
hope so too.
engineer.
Mhm.
Okay.
right, and then-
now we're gonna do the star of the show tonight. Besides you, Ladyada, besides our team, everyone who helps Adafruit go, our community, our customers, and all those great things, including a tiny baby who is super awesome tonight, letting us do the show, is
Yay, cowbell. It's time for more cowbell. This is our second cowbell. The first one was the prototyping one. Usually Data Logger is the second board I make for a platform because it kind of covers a lot of stuff. A lot of people want to do data logging, and they also just want to have an SD card socket. So this is a cowbell. It goes on a Raspberry Pi Pico board, either the Pico or the Pico W, a beautiful silkscreen. Penguin, the Data Logger logo that you guys did, you and Bruce did,
yeah.
and then the cowbell logo. So this is a simple little board that just kind of slips underneath or over a Pi Cow or a Pico, and gives you a real-time clock, the PCF 8523. It's a low cost. It's a fairly good quality real-time clock. And you're going to lose a second or two here, but it's inexpensive, and I think that's a worthwhile trade-off. And then to go with the real-time clock, there's also a coin cell holder. We don't include the coin cell because it makes it very hard to ship if you do, so we sell them separately, or you can buy them at your local grocery store. It's a standard CR 1220. There's also a reset button because the Pico doesn't have a reset button, so you can press that. A micro SD slot that fits nicely at the end. It's a Molex pull type, so you pull it out, pull it back in. And then on the other end is a STEMMA QT port for attaching sensors. So this is basically perfectly designed for, you have a Raspberry Pi Pico or Pico W, and you want to log data from a sensor and you want to timestamp it, or you want to read audio files or data files off of the SD card. Maybe you want to do something with timing. It's a 3-in-1 board, but very handy. All the little individual pieces are very inexpensive, but they fit quite nicely together. So, I put together a very quick little demo that, won't look very exciting, but I can still show it
Wow.
off. So this is, oh wait, I just turned off the light. Can you hit the autofocus for me? Thank you. Okay, so this is a Raspberry Pi Pico, and I've got it wired up over the Stemma QT to a BME 280. And then you'll notice that this LED flashes every 5 seconds. I just wrote a little bit of CircuitPython code, or maybe it was Arduino code, I don't remember, that will read the temperature, humidity, and pressure off of the BME 280 through the plug and play connector, and then log it to the SD card, and then flush that data to the SD card. We'll publish all that data as well. But if you wanted to, this is stacked on with stacking headers that are soldered in. You can add, a battery connector if you'd like. I think we stock one from Pimoroni that allows you to run a Pico off of a LiPo battery that can then be recharged. So you can take it for like portable data logging, or again, you want to host data that has time, sensor input, and SD card. And then, I did some simple things like if you remove the SD card and then, it says like, hey, you remove the SD card, and it, warns you like your data is not being logged anymore. And then on the bottom, oh wait, that's the prototype one. So let me get the final version. It uses the default, thank you. It uses the default SPI port on Arduino. If you're using the Philhauer core, same with I2C, that's for the QT and the real-time clock. And if you'd like, there's also a SD card detect pin. That pin will short low when a card is inserted, or it's the other way around. Basically, you can use it to determine if there's a card physically inside. You can see the little spring that opens and closes when something touches. And a lot of the pins are also duplicated over here. So, you can get to them. They're also labeled. So if you're like, oh, I can sort of solder a wire if I want to get to other IO pins, or you could, like, as seen here, just solder stacking headers and you put it onto a breadboard or another board that you can get to the rest of the components, the rest of the pads, without being in the way of these components. So that is, and then I'll just show on this prototype I do have, I'll show what the battery looks like. So this is when the battery is installed. The prototype is green. Your version will be black, but the prototype is green. And then once you install the coin cell, it'll keep time for up to 7 years.
Wow.
Okay.
And that is new products.
New. Here you go. Everywhere new.
Everywhere new. Okay. Don't forget the code is CalLogger. We have some questions lined up. I've been putting them in a text file for Ladyada to look at as we answer questions. But first, we're going to do some top secret. All right, top secret this week. We can play video. Then we're going to go into the weather report where you point out all of the graphics that were in the background.
All right, Ladyada, what is this?
Yes, we can. We're doing some CAN bus stuff here at Desk of Ladyada. So this is my ESP32S2, and I'm testing out a CAN transceiver that I designed using, I think, the TJA 1051. It's got a little 5-volt booster, and you can turn on and off the termination resistors. And on the other side over here, I've got two SAM E51s are Feather M4 cans. This is one of the transmitters, one of the receivers, and then I'm using this as a receiver, but it's also doing some transmission and basically testing that when I touch it, it receives messages successfully. So this is going to be coming out, and we have CAN IO support in CircuitPython, so that's what I'm using. And then a little preview, we also have a CAN bus Featherwing, which also works in CircuitPython using the MCP 2515. Yes, we can.
All right, so we got this.
weather report.
What is it?
So this is a feather bones board. So it's like, you know, they have the core basic RP2040 board over there, and on the side over your head, I've got ink circuitry for a standard 24 pin ink displays. This is kind of an all-in-one ink display driver, and there's lots of RAM on the RP2040, so it makes for a great ink driver. And then this is the Eagle for a version of the RP2040, but with a RFM module, so it can be like an RFM 69 or a LoRa module. And this is the rendering.
Yeah. And then this isn't a top secret thing. I just wanted to show this. So when we're getting ready, we're like, okay, I might have to like hold the kid or feed the kid while we're doing this. So I'm like, oh yeah, what I'll do is I'll make it so like I could disappear us, and then it'll just be Lamore.
Weird.
And then
Where are you?
yeah, and then I'm like, oh, because now I'm off to the side. But then I'm just like, oh, you know what else is cool? We could have like 3 of you. So this is how we actually, or 2 of you. This is how we actually get everything done. We have 2 Ladyadas. Yeah, that's how we do it. So okay, that's top secret. Our top secret is we have 2 Ladyadas.
Explains a lot.
Yeah. All right. So
Piss bang out.
yeah, we're gonna go right to questions. Do you want to be solo there? Do you want me to just put you in the middle?
Yeah, you want to practice?
Yeah, this is fun. This is fun.
Solo mode.
Yeah. All right.
Well, you're
so-
gonna answer the first question.
Well, I'm just gonna sit here and oh wait, no, I'm not gonna make 2 of you. I'm gonna make
Okay.
1 of you.
Okay.
All right, here you go. You ready?
Yeah.
What's a good way to add shopping cart functionality to a website? Well, I'll be talking head off the screen. So I would start off just putting a button on your site and like PayPal or whatever. I would also lean on like Etsy or Tindy if assuming this is like electronic stuff or eBay, because making a shopping cart is hard.
It's a lot
We just-
different than it used to be.
we were talking about this, like we wouldn't be doing Adafruit in the same way if we were starting now. You might want to look at Shopify, but I think you should get started really easy. Someone can email you, they can PayPal you, there's many ways you could take payment. Any type of credit card is accepted through those things. And just get started slow, because you're just going to end up just doing web work, not, selling electronic work. Next up, these are good ideas, by the way. They're not questions, but I'm going to send this to the CircuitPython team. CircuitPython has a blue screen of death. Someday we'll have a pink screen of death for the web editor. That would be great. There's a ton of possibilities with safe mode now. Amazing stuff. Day and age and developers, and then maybe a pink screen of friendly diagnosis. Yeah.
Well, we have the status bar at the top, so I think we could start with that. Like it
Yeah.
does tell you what line
A
and what
purple screen of help.
what number your error code is on.
Yeah. And then will there be black LEDs? And the answer is, well, we do have these
Funky.
we do have these. This is kind of close.
They're not black, but they're like different colors.
If you turn them off, it's
Yes.
black cat. We have the cat LEDs.
Yeah.
Kind of like that. Next up, Ladyada. You want to read this one off here?
Okay, can an RP2040 handle an ESP32, FONA, and talking to a display driver and some sensors? It has a WQ25 flash for the BIOS and a micro SD slot for the file system. I hope it's up to the task. I think the PIO can handle some of the tasks I'm asking engineer. It can, but that's a lot of stuff for it to do. You might want to skip ahead and use a real-time operating system. I think embed or free RTOS would be a good option, just because that's a lot of data that you're kind of pushing back and forth and handling. It's non-trivial to handle that much stuff. So if you want to have like good reaction timing. Okay, can I
Yeah.
Okay. Why are there 4 circles near the corners of that chip on the eval board? I think that there might be placement fiducials, or I'm not exactly sure, to be honest. I'm gonna ask NXP. Okay.
Or another suggestion was the pink screen of timeout. That's funny. Next up.
Can you put traces under the keep out zone on the ESP room? You can, but you're not gonna have a good time. So I would not recommend it. Keep traces out of there. Not good for your antenna performance and not good for your traces.
Okay.
How do I get 3-phase high voltage meter cowbell for logging? Well, you'll want to get probably like a clamp on thing that can attach to one of the phases. But then you can use this data logger and just read that analog voltage, and you'll just have to, do the amplitude to amperage calculation. But I know that there's like clamp on. I mean, they're not inexpensive, but there's clamps for phase voltage reading. On a previous show, you featured radar capable of detecting movement. General thoughts on carrying one or making a breakout? Just curious. I need to take on these. I have a couple samples of high frequency gigahertz radio radar. They're I have not had a ton of success with them yet, but it could be something I'm doing. So I have to get them working quite well before I can consider stocking them.
Okay, I can answer this one. What's the best location for someone to seek assistance from experienced CircuitPython programmers with the project? They can do the wiring CAD, but programming is outside their skill set. Should they seek assistance in the forums, Discord, Adafruit job site? So do the job site right now because it's going to change soon. So put something up on jobs.adafruit.com. I'll immediately approve the job because we moderate all of them to make sure there's nothing scammy or sketchy or weird. And then you can also hang out in Discord, but if you post on the job board, that's the best way because folks will see that. And then, of course, hanging out on Discord, there's people who do contract work. The forums, those are mostly for customers. But if if you purchase something and it's something to do with the product, they might be able to, of course, point you in the right direction. They wouldn't write the code for you, but those are all the options. So it sounds like you have a pretty good idea of where you got to go. But I would put it on the jobs board as soon as possible. Next up, I think that. What's the best way to add samples to an Arduino sequencer?
You can look at our Neo Trellis board. I think we did a sampler. We would store the samples on QSpy memory, but honestly, CircuitPython kind of does it better because you can just like move the files around. Arduino's not really awesome with like fast access files unless you like embed it into the C code.
And with that is the questions.
Okay,
Good job, Ladyada.
we
You
did
did.
it.
Okay. Guess what, everybody?
Guess what?
That's our show.
Wow.
We very much appreciate you coming by tonight, especially the folks behind the scenes helping out. Jesse May and the Adafruit Slack channels, helping out some customers. Kiddo, who's having really intense dreams. Babies, when they dream, they have every emotion going on.
And she's really slept quite
Yeah.
well.
Also, I really want to say thanks to Sloth.
Sloth.
Sloth is really nice. Also,
Killing it, Sloth.
Ball.
Ball.
This ball.
The great. Ooh, that's kind of cool.
Oh yeah, because it's green.
It's green.
Yeah, it's green.
Big freaky.
Yeah, that's with these. And then I'd also like to thank Crinkle Paper.
Brought to you by. It's the crinkliest.
Yeah. So we'll see everybody next week. This has been an Adafruit production. We're gonna do Moment of Zener, and then our kiddo's gonna play out. Moment of Zener.
Good night, everybody.